Assalamualaikum, my name is Muhammad Zafir Haris bin Muhammad Astaf, nombor matrik DE 230024. So, as the world population and energy needs grow, especially in countries like Malaysia, we must look beyond only fossil fuel towards sustainable alternative. Solar energy is the most powerful resource available, provide more energy in a single hour than humanity consume in an entire year. To capture this, we use solar photovoltaic PV module, which turn sunlight into electricity. This module can be used to create off-grid system, which is independent power setup not connected to the main utility grid. Because the sun only shines during the day, an off-grid system relies on a battery bank to store extra energy to use at night. The system works by taking the direct current DC power from the solar panel, storing in batteries, and then using an inverter to convert it into the type of electricity need to run standard household appliance. This setup ensures a steady, clean power supply even in remote locations where traditional electricity is unavailable. The objective of this project is to first model the simulate off-grid solar system using a proper design tools to make sure it can provide a family energy demand while remaining dependable and efficient. Second, determine and recommend appropriate solar panel, charge controller, battery storage solution, and inverter depending on home energy need and usage pattern. Third, calculate the maximum power demand, total connected load, and load design for Merdeka Mustaf single-story house taking into account trailing average power factor of 0.85. Lastly, compare the plan of grid solar system, initial investment, outgoing maintenance costs, and long-term saving against those of traditional grid energy to determine how cost effective is it.
For the residential load analysis, in general, the application for the diversity factor range is about 60 to 70%. So in our project, we assume the maximum demand is about 65%. So in our total demand is 18.78 kilowatt. So for the maximum demand, we use 18.78 kilowatt times 65%. So we can get 12.21 kilowatt. For the electrical parameter part, we can use with I equal to P over V times power factor. So our load current is 59.84 ampere. So for the safety protections, we choose 63 ampere for the main switchboard, MCB 30 milliampere sensitive RCCB, 32 ampere for the aircon sub circuit, and 32 ampere for the water heater circuit. For the solar PV arrange design and the dimensioning, our choosing panel type is the monocrystalline and type TOP cone. The maximum power of this panel is about 530 watt per panel, and the modular efficiency is 23%, and the open circuit voltage VOC is about 59.8 watt. After calculates, so for our application for need energy demand per day is 89.541 kilowatt per day. So in Malaysia, the peak of the sun hour is about 4.5 hours, so the system efficiency factor is 0.8. To calculate the number of the panel, we can use the energy of the total over energy of the panel. So after we calculate, we get 47 panel. So we round up for the 47 panel, we choose 50 panel instead of real operation condition. Next is about the space requirement. So for a size of the panel is about 2.58 meter square. So for the 50 panel is about 129 meter square. According to the size of single storehouse in Malaysia is about 135 meter square. So that is suitable to install 50 panel solar. For the battery bank size, we use the PV mass lithium T16. This type of the battery required store is 111.93 kilowatt hour. The unit capacity is 12 volt 200 mAh. This design life factor 50% for the maximum DOD. So we only need 94 batteries to require the stock.
Thank you, my friends. Now I will discuss about inverters and charge controllers we use. The solar panels produce DC power, and this DC power cannot be used directly by home appliance, so we use MT 20 kW pure sine wave inverter to convert DC power into AC power for residential use. The inverters works with efficiency 90 to 95%, which helps to reduce power loss. It provides 220 volt sine phase and 380 volt three-phase output, so it can support both normal household appliance and higher power loads. For charging batteries, we use MPPT charge controllers with efficiency of 95%. These controllers work at 360 volt nominal DC volt and can safely handle up to 800 volt maximum input. To increase reliability, we use N+1 redundancy strategy. The charging current is shared among 3 ampere charge controller to supply 60 ampere loads. If one controller fails, the remaining controllers can still keep the system operating. Now let's discuss about system architecture and safety. Solar power is sent directly to the battery bank before AC conversion, reducing energy losses and improving system efficiency. Better charging control helps extend the lifespan of lithium battery bank and ensure long-term reliable performance. Let's move to DC side production. Combiner box for safety connection of multiple BEV strings. DC isolator and DC breakers for safe disconnection during fault or maintenance. Storage production devices up to 1000 volt for lightning and volt storage protection. Last side we have AC side production, MCBS for overload and short circuit protection, RCCB 30 mA sensitivity for electric shock and earth leakage protection. Ensure safe operation, user protection, and reliable long-term residential use.
Assalamualaikum, my name is Aiman Haikal bin Alim, matrix number 8E23013, and I'm going to talk about economic viability and payback analysis. Long-term value with a 20 to 35 year system lifespan, the total saving exceeds 320,000 after the initial payback period, providing a high return on investment. The initial investment was 80,000 ringgit, include panels, battery and installation, and for the annual service saving is 6,200 ringgit. Based on 0.5 or 50 cents per kilowatt per hour utility tariff. Payback period 4.9 years, break even point for the investment. And we can see from the graph that the long-term value is a 20 to 25 year system. Now for environmental impact analysis, switching to solar energy significantly reduce the carbon footprint and promote environmental health through sustainable operation. For the first environmental impact analysis is zero emission, where complete elimination of CO2, SOx and NOx, greenhouse gas during energy production. Directly combating global climate change, 100% clean energy generation. For the second is renewable resource, utilization of abundant, inaccessible sunlight instead of finite fossil fuel, ensuring long-term energy security for the resident, sustainable source. And for the third one is noise reduction. Unlike traditional diesel generator, PV system operates silently, preserving the acoustic environment of the residential area. Silent operation. For the fourth is ecosystem health. No harmful waste product or water pollution, protecting local biodiversity and maintaining air quality for the community minimal footprint. And this is all that our group can think about for the environmental impact analysis. For the conclusion and final verdict, for the first is implementation, energy independence. The system provides complete autonomy from the national grid, insulating the resident from future tariff hikes and power outages. And for the second is financial strategy, long-term cost saving, with a payback period of 4.9 years and 25 years lifespan. The project is highly recommended for its significant return on investment. For the third is next step, system deployment. Proceed with the procurement of N-type TOPCon panels and PV Mars lithium storage to ensure the highest system efficiency.